Okay, now in this mini lecture for Chapter 8, we're strictly going to focus on sample size determination. Might sound like a broken record, but I'm going to take you back to this formula that we learned in Chapter 7. And I remind you that we're going to set the quantity x bar minus mu, in other words, the numerator of this formula. We're going to set that to E and consider it for the moment to be our error term, okay, or the amount of error that we're willing to tolerate, okay. So when we build the sample size formula, we're going to substitute E for this part of the equation here. And I should also have mentioned in the earlier video that if, and Orris talks about this, I believe in Chapter 7 actually, but if we do not know the population standard deviation sigma, it's okay to use little s, which is the sample standard deviation. So just as we use x bar, the sample mean, to estimate mu, the population parameter for the mean for the population, we can also use s, the sample statistic standard deviation, to estimate the population standard deviation. So formulaically, this should come as no surprise, we can set up z equals E divided by the sigma divided by square root of n. In this instance here, we're actually going to use a sample standard deviation because we don't know the population standard deviation. But if you do the algebra on this formula right here, eventually you end up with this formula where we've just isolated n, our sample size, by itself. I remind you that the sample size has nothing to do with the population. The sample size is driven by three issues. One is how confident do we want to be in our answer, and we'll use z for that. Two is how variable are our data. We use the standard deviation for that. And then E, that's just the amount of error or dispersion that we're willing to tolerate for whatever the situation might be. So I just took you through the arithmetic here. On page 130, you'll see Orris's example number 3. And you can read that problem in the book, but there's a company that wants to estimate customer purchases within $2. So this $2 is going to become our E, okay? So this $2 will be our E. They want to make this estimate with 95% confidence, and you'll see that a Z value of 1.96 is what we need for a 95% confidence interval. So we set our model up. S is equal to 5.5. That's given to us. Z is equal to 1.96. We know now that that's the Z value that's necessary for a 95% confidence interval. And E, I should make this $2 here. That almost looks like a Z. Let me erase this once. And our error term is going to be $2. So N equals Z times S divided by E quantity squared. And you work through the arithmetic here and you see that we need a sample size of 30. So calculating how big of a sample do we need is, again, it's a trivial act, and the formula to calculate sample size is actually derived from the formula that we learned in Chapter 7. Okay, so what I would encourage you to do is to work through this example on page 130 in the book. If you've got any questions, don't hesitate to ask. But one of the things that we will give some attention to as the semester goes along is we'll have the reoccurring question of how big does our sample size need to be. Thank you.